Long run cost and economies of scale 14.4. In this chapter, we turn from short run to long run. The output supply condition decision in the long run are less constrained than in the short run for two reasons. First, in the long run, the firm has no fixed factors of production that confines its production to a given scale. The distinction between fixed cost and variable cost disappears. All costs are variable in the long run. Second, firms are free to enter industries to seek profit and to leave industries to avoid losses. In the long run, a firm can vary both the quantity of labor and the quantity of capital. A small firm such as Sam's Smoothies can increase its plant size by moving into a larger building and installing more machines. A big firm such as General Motors can decrease its plant size by closing down some production lines. We are now going to see how costs vary in the long run when a firm varies its plant, the quantity of capital it uses along with the quantity of labor it uses. The long run has important implications for the shape of the cost curves. As we saw in the short run, a fixed factor of production eventually causes marginal cost to increase along with output. This is not the case in the long run, however. With no fixed scale, the shapes of the cost curves become more complex and less easy to generalize about. The shape of long-run cost curves have important implications for the way an industry structure is likely to evolve over time. Firm size and costs. Suppose a manufacturer with a single plant begins on a small scale. As the result of successful operatives expand to successively larger plant sizes with larger output capacities. For a time, successively larger plants will reduce average total cost. However, eventually the building of a still larger plant will cause ATC to rise. The long-run average cost curve shows the lowest average total cost at which it is possible to produce each output when the firm has had sufficient time to change both its plant size and its labor force. A firm's LRAC shows the different scales on which it can choose to operate in the long run. Each scale of operation defines a different short run. Economies and diseconomies of scale. Most firms have U-shaped long-run average cost curves reflecting economies and then diseconomies of scale. Economies of scale or economies of mass production explain the downsloping part of the ATC curve. As plant size increases, a number of factors lead to lower average cost of production. First, labor specialization. Increased specialization in the use of labor becomes more achievable as a plant increases in size. Hiring more workers means jobs can be divided and subdivided. Each worker may now have just one task to perform instead of 5 or 6. Workers can work full-time on the tasks for which they have special skills. Finally, greater labor specialization eliminates the loss of time that occurs whenever a worker shifts from one task to another. Managerial specialization. Large-scale production also means better use of and greater specialization in management. A supervisor who can handle 20 workers is underused in a small plant that employs only 10 people. The production staff could be doubled with no increase in supervisory costs. Efficient capital. Some economies of scale result not from technology but from sheer size. Automobile production, for example, would be much more costly per unit if a firm were to produce 100 cars per year by hand. Early in this century, Henry Ford introduced standardized production techniques that increased output volume, reduced cost per car, and made the automobile available to almost everyone. The small-scale producers will be struck with high cost per unit of output because it cannot spread the high equipment cost over very many units of output. All these factors contribute to lower average cost of the firm that is able to expand its scale of operation. Where economies of scale is possible, an increase in all resources of say 10% will cause a more than proportionate increase in output of say 20%. The result will be a decline in ATC. Constant returns to scale. Technically, the term constant returns means that the quantitative relationship between input and output stays constant or the same when output is increased. If a firm doubles incomes, it doubles output. If it triples inputs, it triples output, and so forth. Furthermore, if prices are fixed, constant returns implies that average cost of production does not change with scale. In other words, constant returns to scale means that firm's LRAC curve remain flat. Constant returns to scale are features of a firm's technology that keeps average total cost constant. As output increases, constant returns to scale occurs when a firm is able to replicate its existing production facility, including its management system. For example, Ford might double its production of Fusion cars by doubling its production facility for those cars. It can build an identical production line and hire an identical number of workers. With the two identical production lines, Ford produces exactly twice as many cars. The average total cost of producing a Fusion is identical in the two plants. Ford's average total cost remains constant as it increases production. Diseconomies of scale. When average cost increases with scale of production, a firm faces decreasing returns to scale or diseconomies of scale. The most often cited example of a diseconomy of scale is bureaucratic inefficiency. As size increases beyond a certain point, operations tend to become more difficult to manage. You can easily imagine what happens when a firm grows top heavy with managers who have accumulated seniority and high salaries. The coordination function is more complex for larger firms than for smaller ones, and the chances that it will break down are greater. The larger firms is also more likely than a small firm to find itself facing problems with organized labor. Unions can demand higher wages and more benefits, go on strike, force firms to incur legal expenses, and take other actions that increase production costs. It is important to note that economic efficiency requires tasking advantage of economies of scale if they exist and avoiding diseconomies of scale. The optimal scale of plant is one that minimizes average cost. Various possible long-run average total cost curves. Economies of scale are rather rapidly obtained as plant size rises, and diseconomies of scale are not encountered until a considerably large scale of output has been achieved. Thus, LRAC is constant over a wide range of output. Economies of scale are extensive and diseconomies of scale occur only at very large outputs. ATC therefore declines over a broad range of output. Economies of scale are exhausted quickly, followed immediately by diseconomies of scale. Minimum ATC, this occurs at a relatively low output. With the current small plant, Sam's smoothies operate on an average total cost ATC1. The other three average cost curves are for successively bigger plants. In this example, for outputs up to 8 gallons an hour, the existing plant with average total cost curve ATC produces smoothies at the lowest attainable average cost. For output between 18 and 16 gallons an hour, average total cost is lowest at ATC2. The output between 16 and 24 gallons an hour, the average total cost is lowest on ATC3. For outputs in excess of 24 gallons an hour, average total cost is lowest on ATC4. The scallop-shaped curve is made up of these four segments is Sam Smoothie's LRAC. Economies and diseconomies of scale. When economies of scale are present, the LRAC curve slopes downward. The Sam Smoothies experience economies of scale for output rates up to 14 gallons an hour. At output rates between 14 and 19 gallons an hour, the firm experiences constant returns to scale. At output rates that exceeds 19 gallons an hour, experiences diseconomies of scale. In the figure, the blue bumpy curve is the firm's long-run ATC curve, or as it is often called, the firm's planning curve. In most lines of production, the choice of plant size is much wider than in our illustration. In many industries, the number of possible plant size is virtually unlimited, and in time, quite small changes in the volume of output will lead to changes in plant size. Graphically, this implies an unlimited number of short-run ATC curves, one for each output level. The planning curve is smooth rather than bumpy. Each point on it tells us the minimum ATC of producing the corresponding level of output. Minimum efficient scale, or MES, which is the lowest level of output at which a firm can minimize long-run average costs. Because of the extended range of constant returns to scale, firms producing substantially greater output could also realize the minimum attainable long run average costs. In some industries, MES occurs at such low levels of output that numerous firms can populate the industry. Example, MES is very small in concrete manufacturing, so there are thousands of concrete makers in the United States. In other industries, MES occurs at such high output levels that only a few firms can exist in the long run. Because MES is extremely large for commercial aircraft, Boeing only has 2 production facilities in the United States. 14.4 Quick Review. The long run is a period of time sufficiently long for the firm to vary the amounts of all resources used, including plant size. In the long run, all costs are variable. The long run ATC or planning curve is composed of segments of shortened ATC curves, and it represents the various plant sizes a firm can construct in the long run. The long run ATC curve is generally U-shaped. Economies of scale are first encountered as small firms expands. Greater specialization in the use of labor in management and the spreading of startup cost among more units of output contribute to economies of scale. As a firm continues to grow, it will encounter diseconomies of scale stemming from the managerial complexities that accompany large-scale production. Minimum efficient scale is the lowest level of output at which firms' long-run average total cost is at a minimum.